Hello, my dear students. My name is Dr. Vaishali Ghai, and the name of this channel is Tricks by Chemistry Guru. So, today we are going to start with class 10, chapter 2, acids, bases, and salts in chemistry. So, let us going to discuss what we are going to study in this chapter. So, first we'll talk about what is an acid. So, here in this chapter, we'll discuss about an acid is a substance whose pH is less than 7. Whose pH is less than 7. That means one thing, it is clear that pH is less than 7 for acid. What is pH? That we'll discuss at the end of this chapter. Then next is when it reacts with bases, it neutralizes these bases and it forms salt and water. Let us discuss an example. Suppose I'm taking an acid of HCl and it reacts with say a very simple base and strong base NaOH. It reacts with NaOH and neutralizes this NaOH to form NaCl and water. So it forms salt and water. So this is known as neutralization reaction. So we can say that acid is a substance that neutralizes base and it forms salt and water. Third property is it forms H ions in solution. That means when we dissolve this acid in water, it produces H ion. So how this reaction takes place? Actually, this HCl in aqueous solution dissociates into H ion and Cl ion. But this H ion when react with water, this H plus when react with water, it actually forms H3O plus ion. We call it as hydronium ion. So H ion actually does not exist. It is the existence of H3O plus ion that exists in nature. We call it as hydronium ion. What we call it as? Hydronium ion. So basically what will happen when acid react or is dissolved in water, it dissociates into H ion that react with water to form hydronium ion. So we can say it forms H ion in solution since H ion does not exist, react with water, so it releases this H3O plus ion. Next important property is it react with most of the metals and liberate hydrogen gas. Though we'll discuss all these properties one by one, suppose I take any metal, say I take magnesium and add HCl to it. So when magnesium will react with HCl, it forms magnesium chloride. Along with this salt, it produces hydrogen gas, and this hydrogen gas is in gaseous state, and thus it goes directly into the atmosphere. Next property is that they are good conductor of electricity, and very important is they are sour in taste. Sour in taste means when we say that the substances which are acids, they mostly are sour in taste. That further, and we'll discuss important point that acids generates ion in aqueous solution as we have discussed just now. So what will happen? Suppose I take HNO3. This HNO3 when react with water. So initially what will happen? This HNO3 in aqueous solution dissociates into H ion and NO3 minus ion, that is nitrate ion. So this is nitrate ion. It react and in water it dissociates or ionizes into H ion and NO3 ion. Now this H ion, which does not exist independently as we have discussed just now, it react with water molecule and form hydronium ion. That is actually how this H ion exists in nature. So hydronium ion will be formed in nature. Next we have is HCl. HCl is hydrochloric acid. Hydrochloric acid when react with water, what will happen? It dissociates into H ion and Cl ion. So once this dissociates into H ion, again this H ion will react with water in this as this reaction takes place, and it forms H3O plus ion. So the same reaction will take place with most of the acid, and this is how the reaction occurs. Let us move further and we'll talk about the classification of acids on the basis of source. So we are having the first thing is in organic acids and inorganic acids. So when we talk about organic acids, we say that these are those acids which are observed, which are present in nature and obtained from plants and animals. For example, when we talk about the sting of ant contains methanoic acid, vinegar contains acetic acid. Similarly, curd contains lactic acid. So these are those acids which are found in either plants or animals that are obtained from nature. Oxalic acid, citric acid, all these are present in nature. So those which are naturally occurring substances or acids, they are obtained from plants and animals. And examples are these. The another category is we are having inorganic acids. Inorganic acids also known as mineral acids. So we call inorganic acids as mineral acids, and they are never present in nature. They are not found in nature. Sometimes they may be strong and sometimes they are weak also. And examples are hydrochloric acid or sulfuric acid. The formula for sulfuric acid is H2SO4. Along with sulfuric acid, we may have nitric acid also. That is also a mineral acid. So these are inorganic acids, and mostly these inorganic acids and mineral acids are comparatively stronger as compared to organic acids. Now let us move further and we'll discuss about the next point. And here we'll talk about the dilute acids and concentrated acid. So this is the next classification. This classification is based on their concentration. Concentration means if the amount is more, we call it as concentrated. If the amount is less, we call it as dilute. Amount of what? So if I'm talking about the acid, suppose I take a beaker and containing some acid to it, acidic solution, and another beaker in which we are having large amount of water with less acid. So water is present in large amount and acid is present in smaller amount. We call it as dilute acid when acid is present in smaller amount. If the amount of acid is more, then we call it as concentrated acid. So it is a comparative term. If we keep on adding acid to water, increases the amount of acid in water and we can make a dilute acid as the concentrated one. It's a comparative term. So when a large amount of acid is present in any solution, we call it as concentrated acid. And when small amount of acid is present in solution, we call it as dilute acids. So this is how we can compare the acids and bases on the basis of their concentration. Let us move further and we'll discuss about one more term, that is physical properties. So in physical properties, when we discuss about the nature, that is they are sour in taste. When we talk about the citrus fruit, when we talk about lactic acid that is found in curd, when we talk about their behavior, we observe that each and every acid we cannot compare it with this with the help of taste. So there is a substance, we call it as indicator, that we are using to find out the nature of a substance. So what indicator is? Indicator is basically chemically a substance that is used to find out the nature of the solution. For example, when we talk about litmus, litmus is one of the indicator. So suppose I'm talking about the indicator, litmus is one of the indicator that turns blue litmus into red. That means we are having two type of litmus solutions. One is the blue litmus and other is the red litmus solution. So this is the nature of acid that turns blue litmus into red. So you need to learn the word BAR bar that changes blue to red when we are having acid. So this is how we can easily recall this term that acid changes blue litmus to red. Similarly, there is one more indicator that is phenolphthalein. This phenolphthalein does not show any change in color with acid, but it changes pink color in base. And another indicator is methyl orange, which is a synthetic indicator and it turns acid into pink. So you need to learn this word methyl orange. M stands for methyl orange, P stands for pink color, and A stands for acid. So if you know that this is map means methyl orange changes into pink when it is mixed with acid or when a drop of acid is added to it or when a drop of methyl orange is added into acid. So indicator is used in very small amount. So here we have discussed three indicators. Out of these three, litmus is the natural indicator that is obtained from the lichen plant. Phenolphthalein and methyl orange are the synthetic indicators, and these two indicators are actually are the synthetic indicators. They are synthesized in the laboratory. Along with these indicators, we are having some other indicators like turmeric, which is also natural indicator and that shows changes in color. Similarly, China rose. The extract of China rose also acts as an indicator that gives different color in acid and base. Similarly, there is one more category of indicator. We call them as olfactory indicator. Olfactory indicator is that indicator which gives different smell in different media, like onion, like vanilla, like cinnamon, like clove. All these are olfactory indicator. They give different smell in acidic medium and different in basic medium. So we call them as olfactory indicator. We'll move to the next property, and next property says that they are good electrolyte. Now my question is why they are good electrolyte? So they are good electrolyte because of the presence of ions. As we have discussed earlier, in aqueous solution, they produces ions, and because of these ions, they are good conductor. Next, we'll talk about corrosive nature. They are highly corrosive. That means they causes severe burns on the skin. So we need to handle all these acids with very utmost care. After this, now let us move the chemical properties of acids. When we talk about the chemical properties, we'll discuss that when acid react with metal, we get salt and hydrogen gas. So I have given you one example of magnesium. Let us take another example of zinc. And this zinc, when added or is mixed with HCl, hydrochloric acid, mixed with zinc, which is metal, it forms a salt ZnCl2 on the basis of the valency of zinc, that is 2, and hydrogen gas has been released. To balance the equation, I'll put 2 out here and the equation is balanced. So what will happen with this metal, zinc metal reacts with HCl, it forms zinc chloride and hydrogen gas. Similarly, when you take zinc with H2SO4, again it forms salt. This time the salt would be ZnSO4 because the valency of zinc as well as sulfate ion is 2. And again the hydrogen gas has been released. So what is the important thing? Important thing is when acid react with metal, it liberates hydrogen gas. Now the question is, how do we judge the presence of hydrogen gas? That means how do we come to know that actually hydrogen gas has been released during the reaction? So we can find it out by hearing the pop sound when a burning matchstick, we bring it near the mouth of the test tube where hydrogen gas has been released. So we can say that hydrogen gas burns with pop sound. Let us move to another property. And another property says that acid when react with base, it forms salt and water, and we call this reaction as, very good, neutralization reaction. We call this reaction as neutralization reaction. What it says that, suppose I'm having HCl and let me take some other example of base, magnesium hydroxide. So this, आपको करना क्या है बेटा, वाटर निकालना है. OH यहाँ से लेंगे, H यहाँ से लेंगे. So we have 2 OH this side, so हमने यहाँ से भी 2H ले लिए. So we get the release of 2H2O. And what we have left with Mg यहाँ पे और 2 Cl यहाँ पे. The formula forms MgCl2. This is how the reaction takes place. इसको आप वापस से कैरी फॉरवर्ड करके देखिए किस तरह से मैंने आपको रिएक्शन बना के दी है. सो यू हैव एनी ऑफ द एसिड विद एनी ऑफ द बेस. फर्स्ट important thing is what you are supposed to do is just take out water molecule from it, and whatever has been left is your salt. We'll move to the next property, and next property says that when acid react with metal carbonate or bicarbonate, we always get salt. Along with this salt, we get CO2 and water. So let me tell you before going to start this reaction what carbonate is. This is the formula of carbonate ion, and the formula of bicarbonate ion is HCO3 minus 1. So when any such acid, say HCl, is treated with say Na2CO3, that is carbonate. So what will happen? First it forms salt. So we can see I'm having Na and Cl, so salt would be NaCl. Second thing is, if we see the reaction, we have left with 2H because यहाँ 2 Cl होनी चाहिए to balance the equation. Na 2 है तो Cl 2 होंगे. To balance the equation, we should have 2 Cl. 2 H यहाँ पे है तो we have left with H2CO3. So it will form H2CO3. But now the thing is, this H2CO3 is highly unstable compound. So it immediately dissociates into H2O and CO2. So wherever this H2CO3 has been formed, it seems to be double decomposition reaction. But since this H2CO3, that is carbonic acid, is highly unstable salt, it readily emits H2O and CO2. So CO2 gas will go off into the atmosphere. And now the thing is, what is the test for this CO2? Test says that it CO2 turns lime water milky. The lime water, which is colorless, it becomes milky when the CO2 passes into it. Next, we'll be having another reaction is acid react with metal salt, metal oxide. So metal oxide, most of the metal oxides are basic in nature. So it forms NaCl and H2O has been formed. To balance the equation, I can write this. And these are the important reactions or the chemical properties of acids. Let us move further and we'll talk about the nature of acid in terms of weak and strong acids. So first thing is, what acids are called as weak acids? Weak acids are those acids which do not ionize completely. What does it mean? Suppose I'm taking an example of acetic acid, CH3COH, and say you take 100 molecules of acetic acid. But this acetic acid is very weak and it does not dissociate all these 100 ions into acetate ion and H ion. Out of these 100 ion, maybe 1 or 2 molecule may ionizes into acetate ion or H ion. So that percentage is less than 5%. That means not more than 5 molecules of acetic acid out of 100 get dissociates or ionizes into acetate ion and H ion. The same is with boric acid, nitrous acid, phosphoric acid, sulfuric acid. All these are weak acids. When we talk about strong acids, we say that strong acids are those acids which dissociates or ionizes completely. That means if I take sulfuric acid, the sulfuric acid, that is H2SO4, it dissociates completely. If I'm taking 100 molecules of this H2SO4, at the end of this reaction, we can see that all these 100 molecules completely ionized into H ion and sulfate ion. So this is how the reaction takes place. And we can say that the acid which ionizes completely, almost 100%, we call them as strong acids, and which do not ionize completely, we call them as weak acids. So next we have is, there are certain examples of common acids, and these examples are like HCl, and this HCl we are used, or we can see that during digestion it is very helpful as it has been released in our stomach. We call it as stomach acid also. When we talk about sulfuric acid is used in car batteries. Nitric acid, that is used in explosives. Acetic acid, the formula is CH3COH, used in vinegar. Carbonic acid is used in sodas, making fire extinguisher, and also in carbonated beverages. Similarly, phosphoric acid, it is used in flavorings, used as flavoring agent also. So these are certain important acids. Now, after this, we'll move further and we'll discuss few more points about acids. So these are the important questions that you're supposed to do. Like, what are acids? Why acids are good conductor of electricity? Explain the change in color of acid with litmus paper, with phenolphthalein, and with methyl orange. And last question is, which acid is found in vitamin C? And I expect that you please give answer in the comment section with your name and class so that I come to know how many of you have responded. So if you like this video, please do like it and click a like button. Please subscribe this channel and share with as many as friends you can. Thank you so much.